Unmute.
Hello.
Yes, yes, sir.
Hello. Hello. You can hear me now.
Yes, you can. We can hear you as well as we can see you.
Okay. Very good evening to all of you. I am Avinash Joshi. I am a foundry technology at present working as a foundry consultant in Kolhapur. I started my career in Gadge Patil Industries way back in 1978 and moved to many companies, at least 8 to 10 companies. One of that was KFIL, Solapur plant. Then subsequent to that, I went to MTech, and then finally Hinduja Foundries Private Limited, Sri Perumbudur plant. I started my career in Gadge Patil as a design and development engineer. I was heading their foundry design office under guidance of Mr. B.K. Shamsundar. And I was responsible there to introduce mold scheme culture and standardization of gating and feeding system for customer, etc., etc. So coming back to the topic, I have been asked to deliver something on Coldbox machine design and machine parameters which we have to take into consideration, as well as design of the core boxes. My humble submission to all of you, both the topics are as vast as one can imagine. Each of them could be a subject of a whole day workshop. So to make it short and palatable, I would like to, I believe many of you are making Coldbox course. So I will ask one simple question, and then with that I will begin the discussion. What should be the tolerance on the dimension of the core across parting line? Can someone tell me? Hello? Hello? I believe you can. Do you listen to me?
You can put it in the chat box as well.
Okay. So, what should be the tolerance for the dimension across parting line in core making? That is the key. This is a very basic thing in our foundry. Okay. Sandeep, should I proceed with?
Yes, yes, please.
Okay. From Rama K to all, from Anil to all. Yes. There are a couple of correct answers, but it should be plus 0.00 to minus 0.2. It cannot be plus side. Now, if you want to make a course with dimensional tolerance across parting line as minus 0.2, there are some aspects which fall in the purview of the core shooters, and there are some aspects which fall in the purview of tools and tooling design and maintenance of the tool. Yes, of course. Now, let us look at the core shooter point of view first. The clamping force of the core box in a given core shooter has to be 1.2 times the opening force. Do we have them? And the opening force is calculated on the basis of maximum area of the core that can be accommodated into that machine multiplied by blow pressure. So 0.8 into that maximum area multiplied by blow pressure is the opening force, and the closing force for that machine should be at least 1.2 times higher than that. My experience in India is we are operating at 40 to 45% of it. Most of the core shooters which are being sold in India are closed with pneumatic cylinders, because they say that on account of productivity we choose pneumatic cylinders, but pneumatic, again, any air is a compressible media. So when you blow a core, the core box tend to open and pneumatic cylinders just give away, and you get oversized cores ranging from plus 0.2 millimeters to, I have seen, plus 1.8 millimeter cores. So this is a non-acceptable condition. And next thing is that when you have core shooters, at the beginning and at every week, the faces of the machine on which the core shooters are mounted must be verified to check and maintain the parallelity between them. That is being done nowhere. Now, having said these things, if someone wants to make a component which is having a minus 2 millimeter dimensional tolerance plus 0.00, in any machine shop, they apply a go and no-go gauge. And we have not adopted that practice in foundry. No foundry checks the cores made on the core shooters with a gauge. Our gauges are made with pattern makers who are not calibrated to make gauges. They make aluminum templates. Now, core which is supposed to be checked within 0.2 millimeters, they make a gauge on some milling machine and apply, made of aluminum. Gauge has to be manufactured by a gauge manufacturer and not a pattern maker. So it has to be a properly hardened, ground and lapped gauge of the required dimension, and a core has to be used. Now, see, if this is a parting line, if this is a parting line of the core, then it is necessary that the gauge has to be applied at one end and at the other end. The dimensions could be different at both the ends, because there can be an opening like this also, or like this. Especially on vertical parted core shooters, the cores could be like this. So this knowledge all foundries can definitely learn from our machine shop guys. If they want to machine a shaft, they use go and no-go gauges. We have to do the same thing. Then, having said all this, we have seen about the clamping force of the core shooters. Then now let me come to the tooling design part of this. As far as there can be, vertical parted core boxes or even horizontal parted core boxes, and design of each of the tools is again it's a whole day workshop issue. But here also I would like to give some tips. The faces of the core box must show perfect blue matching. Blue matching has to be confirmed on the ground, as well as it has to be confirmed after mounting the core boxes onto the machine. If that doesn't happen, you are likely to get oversized cores. As far as core making is concerned, can someone tell me how much fin is acceptable onto the core? Because other two experts have said that the core needs to be trimmed. There has to be zero fin onto the core. Core must be made with zero fin onto the machine itself. No worker can take care of that. He's not supposed to remove the core. Not supposed to remove the fin. As far as the design of tool is concerned, I would like to tell all of you to please refer guidelines given by Ashland. I have this with me. There are a lot of guidelines given into this about what should be the blow area, what should be the vent area, how it should be done, how much amine one should use. You certainly share these guidelines with Sandeep, which again subsequently could be shared onto our group. I would like to throw some light as far as maintenance of the tool is concerned. As Mr. Ramanan has already said, money spent on machines and automation is well spent and you get returns. In the same way, money well spent on the good tooling pays back. Cheaply designed and cheaply manufactured core boxes are the root cause of many problems which foundries never come out of it. I think I have said whatever I had to say in this brief time, and I think it can further be taken into question answer mode. Thank you.
Thank you, sir. Thank you very much. It was a very nice thoughts and lot of learning, lot of educations, lot of new information to all of us. So we'll now move to the question answer session. So right from beginning we'll start. There are some questions already on chat box. What should be dog box tensile strength dimension?
What should be?
Dog box tensile strength dimension? I think anybody can answer from all of four.
Could not understand.
Dogbox tensile strength dimension. I think A.M. Deshpande sir has in his checklist has mentioned about, I think, Dogbox tensile strength.
Coldbox.
Yes.
Acha, Coldbox tensile strength dimension.
It is standard. It is standard. You can refer to any
The dog
book.
bone.
It's a dog bone, yes. It's a dog bone test he's
Standard
talking
dog
about.
bone.
Yeah.
But
1
There
inch
are
is
standards
the,
available.
yeah.
But
It
you
is
may not be able to
available.
tell offhand.
Here I would, add that the dog bone be made as a part of the core box instead of making it separately.
You're right.
If you make it separately into the laboratory, you are likely to get misguided. That may not correlate with what you get onto the machine. So if within the cavities of the cores, if you have one dog bone and get it made along with that, you can get really representative values.
A good point.
Yeah. The next question is, what should be DFT?
Around 0.3 to 0.4 mm.
He also want to understand, explain about DFT.
It's a dry film thickness of paint. There are digital metals are available. We can check it basically. Dry film thickness of paint around 0.3 to 0.4 mm. Thickness of paint. That will depend on the viscosity of paint.
Next question is for Mr. Ramlan sir. Scab defect on casting is more prominent with Coldbox system resin, and how to overcome them?
Many people use some additives and all, like iron oxide, but we never do that. The scab defect is dependent on so many boundary factors. Right from the, for example, storage of cores. You store in a wet condition or a moist condition, it can become hygroscopic, as Mr. Deshpande pointed out. It can lead to scabs. But the scab has to be tackled in a different way, not related to Coldbox. It is basically mold expansion. It can happen in any place, whether it is a cold box or a hard box. It has to be done. For example, maybe the positioning of gauge, positioning the rate of filling of the mold, and other factors. The cold box need not give rise to scabs. This is our experience.
How long we can dry a Coldbox core in oven?
One hour or 1 hour 10 minutes.
Can I say something?
Yeah, please.
As far as the choice of oven and choice of a trolley is concerned, the basic of Coldbox core making is, once the core is made, it must be painted within 3 minutes from making the core. And once it is painted, it must enter the preheating zone in further 3 minutes. Violation of any of these two conditions definitely lead to variations, either moisture pickup of cores, and can lead to casting defects. So the Coldbox core which is made must be painted within 3 minutes from making, and a painted core must enter preheating zone of the oven within 3 minutes. In that case, if we have a trolley and there are 10 cores on a trolley, and if we paint one core and keep it and paint 10th core of it and put it into, we are already lost. So from that point of view, a continuous oven is always preferred. The second thing is that Coldbox core should be dried at 160 degrees centigrade maximum. It should not go beyond that. And then further, it has to be cooled. I would also like to add here that a temperature of the core which goes into the mold must be maximum 5 degrees than the temperature of the mold. If it is more, you have problems. And the temperature of the core means not temperature of the core at surface. Somebody can experiment. Take one core, measure the temperature of the core at surface, just cut section it and find what is the temperature inside. That inside temperature has to be a room temperature. Till that time, the cores are supposed to be cooled. If not, there are problems like colder metal, or there are problems of this explosion penetration.
Okay, next question is how to check proper mixing. How to check proper mixing of sand?
Mr. Gore or Mr. Deshpande can speak on it.
How to check is difficult. Basically, proper maintenance of Muller or mixer is important.
Gore sir already explained about that maintenance of Muller.
Yeah.
I think that has to be taken
Followed.
care. Yeah.
Here I would add one. Yes, maintenance of mixer is one. Cleanliness of mixer is of utmost importance. Cleanliness of resin and hardener addition is utmost importance. There are weekly schedules, and how to do it. There is Tata Motors, they use groundnut oil to clean that once a month. So there are different ways and means about how to clean it. And another thing is that once the mix is made, this can also be checked with dog bone tests, either separate. Best way is to make it, integral with the core. These are the ways. And there is another thing, how to ensure the quality of the mix is, the size of the mix has to be controlled to at least 4 to 5 cycles of the core making machine. It must not be more than that.
Talking about bench life.